to meet the class is 7 p.m. to 8:30 with a mini break. So, and the syllabus I'm gonna share with you is this one. Welcome to our thermodynamics class. It is highly recommended that you attend the lecture um, online. If there is no other issues, you can always watch these lectures, recorded lectures later on. And please feel free to ask me any questions during the lecture or after the lecture. If you have any difficulty in the quizzes, assessments, technical problems, like I received an email today that somebody has a problem in lockdown browser. So I would try to fix that problem. So this problem for the lockdown, all the tests will be lockdown browser. So mostly there will be MCQs and problem solvings, so written response. So once you are done with the MCQs, or I would ask you to upload your exams on the D12. Okay, this is my introduction. My name is Muhammad Salman. I've been here since 2012 at Kennesaw State University, and then I have taught this class quite a few times. And the book which we are following, it is seventh edition of um, this um, Cengel and Boles, Michael. So you can either buy this, and there are some version online available. This is up to you, but it is recommended to buy this book. You may be find you may be able to find this quite cheap, and this will be useful for your future courses as well if you want to do your master's level or some kind of job related with the HVAC or something, thermo related job. All right, so I feel that you guys already have taken this maths 2253, physics 2211, 1111, and then these are the prerequisites for this class. The learning outcomes, you will learn key thermodynamic concepts, and you will be able to read the ideal gas data at the end of the chapter, at the end of the book. I will show you when the time comes how can you read those tabulated data from the book, and all the exams will be open book, but you are not supposed to have the solution of the homework problems in front of you when you are taking the exam. You are allowed to take one formula sheet during the test, and the exams are open book. You will be analyzing processes involving ideal gas, working fluid in both closed systems. I will explain what are the closed system and open systems in detail in chapter 2. First law of thermodynamics. It is the law of conservation of energy principle and control volume. Second law, the concept of entropy, introduction to thermodynamic cycle. Okay, so these are the topics which we'll be covering. And the grading policy is that you will have A, grade A, if you score between 90 to 100, and so on. There will be homeworks every week mostly, and they will help you to understand the concept. It is recommended to work in a group of two students, but if you want to work alone, this is also uh, possible, or it is also allowed to work alone. Or if you want to work in a group of two, it is also permissible. And then you will be having 3 to 4 quizzes in covering 30% of overall grades and three tests covering 60%. And these three tests will be including the final exam. Each test is 20%. And yes, if you have any question, yeah, these are the layouts. And remember, I will always announce the test 1 week or 3 or 4 days early. Since this is a very compact semester, so usually the time frame to prepare for the test and quizzes, I would announce it 4 to 5 days early. And mostly the quizzes, like we will have a quiz in the second week. They are mentioned here. I will try to follow this syllabus, but if not, then I will mention. Sometimes the dates might be changing, but if there is some change in the, like if I say fourth week, you may have a quiz too earlier in this time slot, so I have to announce it so that you should be able to prepare for the quizzes. All the quizzes and tests will be announced for you to get prepared quickly. All right, so the final exam will be on July 26th. Now the time is it will start from 7 p.m. on Wednesday. Initially the time was 6 p.m., but I received a few emails that some students they work, so they cannot attend the class at 6 p.m. So I thought it is good for them to change the time slot from 6 to 7 p.m. So now our classes will be um, happening in this time slot from 7 p.m. to 8:30 p.m. Okay, you can open your mic now to talk if you have any concern about the syllabus, and I will try to answer those questions if you have. All right, so if you don't have any question, let us start our lecture now. Okay, some students ask me, will need a physical book to use open book test since will. Yes, it is recommended to use a physical book, or if you have another like device with you, I would not say to use another laptop because you need the book for reading the tables. Like I will show you. I will show you in the book you have to read the table at the end of the book, so it is required to use the book during the exam. You cannot solve the questions without the tables written at the end of the chapter. Okay, so let us start our, just for instance, I want to show you this is on page, 1 second. This is on, suppose if I give you a questions to find, this is just an example of the screenshot of your book, page 968. So if I give you a question, find out the property of superheated water. So you need this table to find out these properties. For example, internal energy, enthalpy, entropy, specific volume. And if I ask you what is the internal energy of water at 1 psi absolute and 700 Fahrenheit. So you have to draw You need the book to read this table. The If I ask you for the entropy, this is 2.3146 BTU per pound mass per ranking, and that's why we need to have the book. But you don't need to. You are required not to have the solution manual in front of you. All right, guys. Okay, let's open the slides. Okay, chapter one. Chapter one is introduction and the basic concepts. Okay, so you will learn about the basic concepts in this chapter. So some of the thermodynamic properties and systems of units, SI system and English system. If I say SI system, which has the units of mass as kilogram and distance as meter, or the length as meter, and time is second. Time has the same unit in both systems. English, you have foot pound second. In an SI system, you have MKS. Um, so meter kilogram and second. Explain the basic concept of thermodynamics such as system, state postulate, equilibrium, process, and cycle. Review concepts of temperature, temperature scales, pressure and absolute, and gauge pressure. Introduce an intuitive, systematic problem solving technique. Okay, okay. Thermodynamics is the science of energy. Energy is the ability to cause change, conservation of energy principle, that the energy remains conserved. So, some of the slides I would suggest you read by yourself, and I'm gonna solve few problems for you. Okay, so let's do some example of first law. As far as this example is very easy to understand. For example, if you have a if you have like a heating source, and you are heating some kind of container. So, okay, and it has water in it. And we call this as a heat entering the system. Heat is entering, we call this a Q in. And what it does, if you are covering the container with a lid, it has certain uh, force of the weight of the lid. It is W. So weight and the lid can go up and down. If it goes up, it covers certain new state. So Q in, and the suppose, for example, in this example, I say the lid is rigidly fixed. You have just screwed it, and now what will happen? The energy of the molecules will start increasing. We call this as um, internal energy. I would say you can write out U is internal energy of the fluid. Of the fluid could be water or any other substance, but U is the small u is the specific energy, but and Q in the heat supply, heat supply, and Q in equals to U2 minus U1. And this, whatever Q you are supplying to this container, it is increasing the internal energy of the molecules, like kinetic energy of the molecules. They keep on vibrating back and forth. And when you increase the heat energy, that energy is used to increase their vibration, and then the distance keeps on increasing, and it causes the heat. and and the internal energy final is U2, initial is U1. This is the first law of thermodynamics. First law of thermodynamics states that an expression of conservation of energy principle, whatever energy you are supplying in terms of heat, it is used to increase the kinetic energy of molecule or increase the internal energy of the fluid. And if I change this system, like if I change the system such a way that it is not, it is having a movable container. So now the lid it can move up and down. So what will happen if you, let me change the color here. So if I want to change the color to show you, look here, this is the hue is being supplied, hue in. And if the lid moves to the next position 2 from position 1, so this lid has moved from position 1, we call it as V2 minus V1, we call it as V2 minus V1, change in volume. When you see the change in volume, and this lid has its own weight, and weight per unit area is the pressure. So when you see the work done by these molecules in lifting the container from position 1 to position 2, it is generally written as this formula. What this formula says, that the work done by the system, we call this as system inside the imaginary boundaries. You have to make some real, right now these are the real boundaries, because the container has its own boundary, movable boundary, and the a lid has a movable boundary, and the rigid boundary by the container. So if I say pressure is constant, so let me show you. So the work done is the work output, work done by the system, we call it as work done by the fluid. And now in this case, since the work done by the fluid in moving the lid from position 1 to position 2. Look, from position 1 to position 2, pressure remains constant because weight per unit area, weight of the piston is not changing, area cross section is not changing, the pressure remains constant. So if I say, if I write down the first law of thermodynamics, first law for this system, I would say heat supplied minus work out, change in the energy. In this case, this energy only. So I would say this one. We will study more about it. This the heat supplied in the movable lid. Some of the heat is utilized to move the lid to position 2. In this case, there is zero work done because this lid is rigidly fixed. And the first law can be written like this. All of the heat energy is used to increase the kinetic energy of the fluid molecules. In this case, since the piston is movable, therefore some of the energy is used to increase the kinetic energy and some of the energy is used to move the piston upward. Therefore, we have to subtract that amount of energy from the heat supply. Suppose if I tell you 10 joule is used to supply the heat, and then 2 joules are used to move the piston upward. Remaining 8 joules. Now, this is the perfect example of the first law of thermodynamics that the energy is conserved. And in this case, if I write down the quantitative values, heat supplied is 10 joules. All of the energy is being used to increase the kinetic energy of the molecules. This is first law of thermodynamics. And look, in this example, what's happening here? That it is the energy is conserved. Potential energy is 10 joules. Kinetic energy at this location. Suppose this is position 1, this is position 2. At this position 2, the sum at any location at position 1, the sum is 10 units. Potential energy plus kinetic energy, the at position 2, the sum is 10 units. Units, usually the energy has the unit joules. Do you understand the concept of? If you understood the concept of first law, please type in yes in the chat box, and then I will move to the next concept. Seth says yes, Macy yes, Jack say that's good. Okay, that's good. Thank you. I want to write down. We will write down something more. I just alluded it to you a little earlier that what is first law of thermodynamics, but you will see this equation uh, in the coming slides. Okay, let's go to the next. Okay, I'm not going to explain you each and every law or principle right now, but second law states that you cannot have the work without um, expenditure of energy. You have to have some amount of energy going in and coming out, energy stored. We will talk more about it, and it asserts that the energy has quality as well as quantity, and actual processes occur in the direction of decreasing quality of energy. And we will talk more about it. That um, second law states that quality is the property by which we can judge that energy is being lost due to the friction, or we have to have certain kind of energy loss. I give you a very big example of our daily life, of our, like, if I give you example, let me show you example of our daily life. Everybody has car. So the engine, suppose this is the front, the engine is here, and the engine, the the fuel, the gas burns here, and the heat is being supplied here. And suppose this is 100 joules. Heat generated by the engine by burning the fuel inside the cylinder is 100 joules. And then you have a tailpipe. You have a tailpipe, and the energy coming out of the tailpipe to the surroundings is 60 joules. And then the work done is Q in minus Q out. 100 minus 60, 40 joules. And efficiency of this engine, of this car, is uh, the work done divided by the Q in is 40 divided by 100 times 100. So if I do the math here, so I'm sorry, this is 40 by 100. So it's 100, 40, 40%. So the efficiency of this car engine is 40%. You will see later on when I will teach you second law, you will see that no car or no, it is impossible to get the work done out of any heat engine without without sending energy to the environment, or without the expenditure of the exhaust. You have to have certain kind of exhaust system. Without energy release, we cannot get the work output of the, because we have to channelize the energy. If we don't have a channel of energy, then you cannot get the work done. Look, right now, suppose in the environment everywhere, suppose we have 100 Fahrenheit. Suppose if you do not channelize this energy into a certain stream, then you when you channelize this, you can generate energy by using a propeller inside this channel, and this is the work done, and this is the release of energy, like at maybe at 20 Fahrenheit. So when the energy flows from high temperature reservoir to the low temperature reservoir, then you can, the thermodynamics engineers, they thought of, if the energy flows from high temperature reservoir to low temperature reservoir, then they can use the same concept, and they can put a turbine or a piston to generate the work done that is utilized to do multiple tasks. So do you understand the concept of that? You have to expend some energy to the reject it to the environment in order to gain you have to channelize the energy in a proper way to get the work output. This is the concept of the heat engine. And if you just a brief over, it is not at this moment, but I'm just, this is the first lecture, I just want to allude it to you. This is the example, this is the example of heat engine. But if I want to flow the energy from the cold temperature like 20 Fahrenheit, q low temperature, 200 Fahrenheit, q high, then you have to have the work input. This is work done output. Now you see this example is refrigerators. Our refrigerators or ACs, they work on the principle of work input. Do you know where the work input is coming from? You have HVAC system in your houses, you have refrigerator. Can you tell me the name of that device which is very important in every refrigerator, in every air conditioner? Without that specific device, we cannot have work input. Can you write down that particular name? It's very famous. What is the name of that device which is used to supply the work input? To move the heat from one location? Compressor. Good job. Good job. Compressor is the right. Every AC, every refrigerator must have a compressor. A compressor is used to, you have to have a compressor. It is used to move the energy from evaporator. You are like in a refrigerator, you have the produce inside the refrigerator or the freezer, and over here it's low temperature, 20 Fahrenheit in the refrigerator, and you are again taking the heat out of the low temperature and rejecting it through the condenser, and you have a compressor. Compressor is used to let the heat flow in the opposite direction. The natural direction of the heat is always from the high temperature reservoir to the low temperature reservoir. But if you want to move it in the opposite direction, then you must have an input source of work done to move the energy. It's a similar case. Like for example, if you have a hill and uphill, it's a dam, water is reserved here, and you have made a channel. Sorry, this is a channel, turbines here, and the water streams. So water from here, from this head, it passes through the turbine and it generates work output. Water flows from high elevation to the low elevation. Now here, this is H0. This is, now this is the pressure head. Pressure head is delta H, mg. I will say delta H, mg delta H, potential energy. But now, if I want to move the water from the low elevation to the high elevation, you must have a device known as a water pump. Water pump is the work input. It is just like a compressor to let the heat flow from the unnatural way. Unnatural way means from the evaporator to the compressor, or from the low temperature reservoir to the high temperature reservoir. This is the second law. You will study more when the time comes. We will study about the refrigerator cycle, study about the heat engine cycle. We will study. This is our overview, so therefore I'm explaining a little bit in detail in the first lecture. Classical thermodynamics, macroscopic. Macroscopic means large scale approach. We consider as a continuum mechanics, like we don't consider like at um microscopic. Microscopic means at molecules levels. We will not study at molecules level. So there is a vast application of thermodynamics in every field. In houses, we have HVAC system, refrigerators, and the airplane engines, HVAC air conditioners, steam turbines. Everywhere we have vast application of in the variable dimensions thermodynamics. Now we come to the next topic, which is system, unit system, SI system, as I mentioned. So you must know unit system. Length has meter in SI system. Mass has a unit kilogram. Time has a unit second. Temperature has a unit Kelvin. Electric current has a unit amperes. Amount of light is candela. Amount of matter is mole. These are the fundamental units, and some of the prefixes: tera, giga is 10 to the 9, in mega 10 to the 6, kilo 10 to the 3. At least you should know these, and from here you should know nano, micro, milli, centi. These you should know. Some of the units conversions are written here. So, okay, look, 1 pound mass. This pound has unit like if you see lbm, which means that pound mass, it is 0.45 4 kilograms, and 1 foot equals to this 0.305 meters. 1 joule is 1 newton meter. 1 calorie is 4.2 joules. I'm just rounding this off to 4.2 joules. 1 BTU is 1.055 kilojoules. Force equal to mass times acceleration. This is Newton's second law, that when the mass is considered to be as 1 kilogram, if you apply the unit Newton for 1 Newton force to generate the acceleration, and 1 Newton equals to 1 kilogram meter per second square. On the other hand, if I write down the same in terms of 1 pound force equals to 32 pound mass foot per second square. These are the units conversions, and two types. So we will be learning our problems in both systems, because in the industry sometimes we are still using pounds, feet, inches, and therefore students should know how to solve the problem in both units. Usually in Europe they are using SI systems, and in America they are using English systems, and in Asia they are also using SI systems. So you should know as a problem solver that how to solve the problems if you have different units. It's not difficult. I assure you can easily solve in both cases. Okay, the mass is same. The weight of a person on the moon is different than weight of the person on the earth due to the gravity. A body weighing 60 kilogram on earth will weigh only 10 kilogram on moon. W equals to um 1 kilogram force, or 9.8 newtons. W equals to 1 pound force, or 32 pound mass feet per second square. The gravity on the earth, it is 32 feet per second square. Gravity on Earth in SI systems is 9.8 meter per second square. Hmm. So dimensional homogeneity, what it means that unit consistency. So that's it's not difficult. 1 Newton equals to 1 kilogram meter per second square. And on the other hand, in English system, 1 pound force equals to 32 pound mass feet per second square. Now the next concept is systems and control volumes. And systems a quantity of matter or region in a space chosen for study. So you have some boundaries. You either make um, real boundaries as your boundaries or imaginary boundaries. So the boundary, real or imaginary boundaries. When you draw some boundaries, then everything inside the boundary is known as a system. Closed system, when the boundaries, the mass cannot go inside or cannot come outside. No mass can transfer inside the closed system. But in an open system, mass can also move in and out. In this example, this if I consider this system, this is the boundary of open system. This is open system. The mass can go inside and outside. But when you see the mass is enclosed inside the container, the closed system, energy can transfer, but mass cannot transfer. The boundary can be movable or fixed. System may be considered to be closed or open. Closed system when you have control mass, a fixed amount of mass and has no mass, and no mass can cross the boundary. Now I want to show you example of the open system. Look over here. This is an open system, like our water heater, a properly selected region. This is our boundary system. And water comes in. Water comes in, cold water comes in, enters here and leaves here. Hot water leaves. When the mass can enter or leave the system, it is open system. In this case, the mass is entering the system. This is also open system. In this case, the nozzle, and suppose this is a water hose, a mass can enter and leave the system. And leave the system means leave the boundaries. Open system, a properly selected region in space. All the devices, compressor, turbines, nozzles, that involves the mass flow. One thing I want to mention, although you haven't studied, but when the mass, I would say fluid mass flows, it carries energy, and that energy is known enthalpy. H you will study later on. Enthalpy It is the energy. For example, water in a water hose, it has a temperature. Suppose a water at maybe 60 Fahrenheit or 70 Fahrenheit, it has enthalpy. Unit is kilojoules per kilogram. And if water, so every fluid has energy written by the when it is moving. When the fluid moves, it possesses enthalpy. And if it does not move, if the fluid does not move, stationary fluid, like in our case, like closed system, look, closed system, this is just internal energy. Internal energy. You see my point? This is when the fluid or the mass flows, the energy, actually, this has both, this is due to the molecules internal energy, and this is the flow energy. You will study later on, but I'm just telling you that you will study about entropy, sorry, internal energy, enthalpy, pressure times specific volume. Pressure times volume is a flow energy. So there are some properties of fluid. Property, any characteristic of a system. For example, if I say mass, volume, temperature, pressure, density, these are the properties. Some properties, they depend upon the mass, some don't depend upon the mass. So intensive properties are those that are independent of the mass, such as temperature, pressure, density. Extensive properties are those that depend upon the mass, on the size, such as volume. And specific properties, extensive properties per unit mass are also specific. You are specifying. For example, if you see, in the bucket, if you have 5 gallons of bucket, and the volume is 5 gallons, but small v, specific volume, you are specifying specific volume. Always specific quantities always are small letters. This is small letter, this is big letter, this is actual volume, 5 gallons bucket. But the specific volume, you are specifying per unit mass, like total volume. Suppose this is total volume divided by the mass, whatever the mass is, like in our case, like 5 gallons, suppose 10 kilogram. So it, you are specifying it. For example, if you say the mass is 1 kilogram, so 5 gallons per, usually we write down in a meter cube per kilogram. I'm just writing down gallons, but you should know how to go from gallons to meter cubed, because it is important to convert. And suppose if I tell you 1 gallon is how many liters? 3 point, I believe 3.7 liters. Can you please write down in the chat box how many liters in 1 gallon? 3.78. 3.78. Okay, so this is our conversion. And we know that 1 meter cube equals to 1000 liters. We know that. Now you can convert 5 gallons, how to go from 5 gallons to meter cubed. We know that 1 gallon equals to 3.78 liter. And we know that 1000 liters equals to 1 meter cube. That's it. So we are left with we are left with 5 times this one. So what are we left with? If you do the math here, what do you guys get? I'm not sure why the system is stopped. 5 times 3.78 divided by 1000. So it is the specific volume 0.0189. The same concept by Brina. Yes, thank you. Okay, that's good. So this is the specific volume. This is how you will find out the specific volume of a fluid in your problems. Okay, now the next slide is talking about continuum. Continuum is a word used uh, for um, macroscopic way. Like you don't worry about the um, at atomic levels or the molecules level. Matter is made up of atoms that are widely spaced in gas phases. Yet it's very convenient to describe atomic nature. So continuum means that there is no dips and ditches. You just consider as a uniform gaseous matter, and we will consider our in our cases everything is at macroscopic. Macroscopic means that continuum based. It is there is no atomic level changes. We are not studying at nanoscale or microscale. Okay, the next property you will learn today is the density. And density is mass per unit volume. Please write this formula in your formula sheet. You will be using density a lot of times. And the next formula you should write down specific gravity. It's a ratio of two densities. Density of a substance divided by density of water. Density of water, it is 1000. Density of water, it is 1000 kilogram per meter cubed. And if you compare specific gravity for water, it is 1, and blood is thicker than water. This is 1.05. Seawater, so you can keep noting down. The bones is 1.7. Mercury is very, very dense as compared to water you are comparing. And specific volume, as I mentioned earlier, you can specify volume dividing by the mass, which is the reciprocal of density. Our density is written like mass per unit volume. Specific volume is volume per unit mass. It is also known as inverse of density. Another thing you can see, rho g. Rho g is the specific weight by gamma, the weight of a unit volume of a substance times rho g. So mass per unit volume times gravity. Mg is the weight and volume is the volume. So gamma, it is also known as specific weight, weight per unit volume, rho g. Up until now, if you have understood these slides, please type in yes, and then I will move to the next slide. Okay, good. Some students are writing yes. Darius, Jay, KP, Christian, Sinchana, they're all typing yes. That's good. But if you don't have any clarity, please you can ask the question here. John, Eric, that's good. State and equilibrium. Now, before I move forward, can you tell me what is this system? Is it closed system or open system? Please write down in your chat box for these containers. Is this closed system or open system? That's good. This is closed system. No matter is entering or leaving, but heat can enter or leave the system. And I mentioned in the beginning, look, in the beginning, I gave you an example of conservation of energy principle that the closed system here, this is also closed system, the heat which you're supplying to the fluid, it is lifting the piston or lifting the lid upward. And in this case, it's the same thing happening. Look, now over here, this is the lid. You are somehow uh, now there is lid has been moved, but how has it been moved we don't know right now. But what it is saying here, a state can be defined by two independent properties: temperature volume and temperature volume. So if I draw temperature versus if I draw a plot, temperature is at location one. This is state one. At locations one, the temperature is 20 Celsius, and the volume it 1.5, it is in meter cubed. Okay, and the next time it is 20 Celsius, the temperature remains constant. Okay, it does not change. The volume increases to 2.5. Okay guys, if I draw the line joining these 2 points, this is the process direction. Process is going from state point 1 to state point 2. This is how you have to show me on the plots, temperature versus volume. Some plots are temperature versus uh, internal energy or some volume, some pressure versus volume, pressure versus volume. You should be able to define the state using two properties. If I say pressure over here, uh, it is 10 psi. Here volume is 1.5 and the pressure is. So these are the state points. The state of a fluid, it is defined completely by two independent properties like temperature volume, pressure volume. And look over here, what is thermal equilibrium? Equilibrium is a point where there is a balance. And thermal equilibrium, when suppose over here the temperature of the fluid is 20, here it is 30, it can happen. Yeah, it can happen somewhere. Temperature in certain locations is different, but after some time, temperature everywhere inside the container is uniform. This is known as the thermal equilibrium, and it is also known as zeroth law. So you have studied today, you have studied the first law. Look, what is first law? You have studied the first law a little while ago, that energy remains conserved. It just transfers from one form to another form, but it initial and final energy, the sum is always same. You have studied second law, that you cannot make a heat engine without the expenditure of energy. You have to reject some heat to the environment. You have studied um, second law, refrigeration system. And now you have studied the zeroth law of thermodynamics. What is that law? That if the temperature of the fluid is uneven, it becomes even or uniform after some time. For example, if you join two bodies at different temperature, suppose this is at 100 Fahrenheit, this is 10 Fahrenheit. After a certain time, like if you say like 10 minutes, temperature is 60. For example, this is equilibrium. We call it a zeroth law. So I have taught you three laws today. Zeroth, first, second, there is third law as well. Third law I will teach you very briefly today, but we will study more. It is about the entropy. Entropy is zero at 0 Kelvin. Like a crystal. You see, crystals are so defined atoms, very defined atoms. Diamond crystal. So at 0 Kelvin, if you decrease the temperature of any, like even if you decrease the temperature of water to 0 Kelvin, water become crystal. And at crystal level, which is very, very tough, difficult for us to drop the temperature to 0 Kelvin. 0 Kelvin means, you know what it means? It is negative 273 Celsius. And at that point, entropy is zero. This is just a brief overview of third law of thermodynamics. Second law, you have studied heat engine and you have studied refrigeration cycle, refrigerator system. First law, conservation and equilibrium. So today I gave you a brief overview of what you're going to study throughout the semester. We will study each principle, each law in detail. This covers the whole chapter in our future lectures. Don't worry, I'm not going to explain everything today, but we will learn more in the coming weeks, and there will be interesting chapters coming soon. Okay, the state postulate. The number of properties required to fix the state of a system is the state postulate. The state of a simple compressible system is completely specified by two independent intensive properties: temperature and volumes. Volume is intensive. Volume is without this is specific volume. When you specify an extensive property, it becomes as intensive property. Let me show you what it means by when you are specifying volume itself is depend upon the mass, like over here the extensive property. But when you specify the volume with a certain mass, then it becomes specific property, which is also intensive, kind of intensive property. So now let me show you the plot. I drew a plot like this, you see. Okay, before I move forward, I just want to allude to you what thing in this plot, which property is constant, volume or temperature. Please type in the chat box for this plot. Good. Rina says temperature. That's correct. Now, if temperature remains constant throughout the process, the line shows a process. Remember, we will study more about it. Process is in a certain direction from one state point to another state point, or one equilibrium state to another equilibrium state. This is known as the process. If the process, if the process is uh, happening at a constant temperature, This is known as isothermal process. Iso means constant or same, and thermal means temperature. Like isothermal process means constant temperature process. Now, in the next plot here, which property remains constant throughout the process? Can you type in that property? What property remains constant in the second plot? Pressure. Good job. Pressure remains. Look, it's a straight line. Pressure versus volume. Now, if pressure is constant, we call this as isobaric process. Isobaric, like bar is the unit of pressure. Isobaric process. We will study more. Okay, now let's go back to this state, a process, any change that a system undergoes from one equilibrium to another equilibrium, so from one state to another state. And this line is telling us the process. When you have slow compression, it is quasi equilibrium. Like every stage you can define the points. Like if I ask you, can you tell me what is the property A, property versus property, you can easily locate. When you have a solid line, it's a quasi equilibrium process. But when you have a dotted line, like let me show you, when you have the same process from 1 to 2, when you have dotted line, only the final initial and final processes are at equilibrium, but in between the processes cannot be traced. This is known as non quasi equilibrium process or irreversible process. You will see this word many times. Irreversible process which cannot be traced during this execution, but this is a reversible process. Reversible process that can be traced throughout the process, um, conduction or execution. You see, and the example for this one, if you take a look, very fast compression, and or if you have a flat tire, if you have a flat tire, then you suddenly lose air pressure of tire to the environment. That is irreversible process. So you will study something more about reversible and irreversible, and I'm going to show you, just allude it to you, that for a reversible process, and there is another process known as adiabatic process. No heat transfer. Like if everybody wants to save energy, like in our house, you see our drywalls, you see drywalls. What is behind the drywalls? Insulation. Every stud, if I go 2 by 4, usually they have cover all, and the attic space or the ceiling, they are all insulations. Why do we need insulation? Because our air conditioner ducting system is maintaining the temperature inside, like 70 Fahrenheit, to keep us comfortable temperature. And when there is no heat transfer, ideally, then this is known as adiabatic process. Perfectly insulated process. There is no heat loss of the system. And when you see perfect, when there is no heat loss, when Q is zero, reversible process, when reversible process, Q is zero, entropy is constant. We will study more. We call, and when you see the property, when you see the two property, like if I define specific volume versus entropy. And if you have process from one equilibrium state point to another equilibrium state point, the process happening, entropy is constant. It is because you have perfectly insulated the container, and it is completely reversible process. All the points are traceable. Then it's a entropy remains constant throughout the process. Entropy just a constant. Let me tell you, entropy is the amount of energy. It is telling you the quality that during the process, if you lose the energy to the environment, then you are increasing the entropy of the system. You should, if you have a constant entropy, it means you are not losing energy to the environment. We will have more conceptual uh, things comprehension later on, but I'm just alluding it to you that what are the different types of process and what is the significance of, if you see constant entropy process, you should certainly say that it's perfectly insulated process. The heat is not lost or entering the system. Another kind of, look over here. Oh, I'm showing you this. Look over here. We talk about ISO, means constant. If you have constant temperature, isothermal. If you have constant pressure process, isobaric process. If you have constant volume process, isochoric process. A cycle is like, if you have a cycle means, if you, let me show you a cycle. Oh, I'm sorry. This a cycle is in a process. It should be more than two processes from one state. Suppose if the state equilibrium is here, equilibrium is here, equilibrium is here, and it's here. So the process is happening like this, from 1 to 2, 2 to 3, and 3 to 1. It comes back to the initial equilibrium state. This is known as a cycle, like we usually call from 1 to the 3 in a cycle. What is the total work done in a cycle? In a cycle. You see my point, guys? So you can find out a process during which initial and final states are identical. This is a, a cyclic process. Then comes another point, steady flow. Okay, steady means that constant energy flow process. Steady, no change or constant. Or the opposite is unsteady, transient. A large number of engineering devices operate at steady flow, and steady flow process is the fluid flows through a controlled volume steadily. The fluid inside the container remains constant. Let me explain it to you. So if you have a, a container here, and the volume and the fluid is entering, mass is going inside and leaving the system. Look over here, the control volume, it has over here the temperature is 300, at this location 250, 200, 150, and then after certain time during the steady flow process, the the temperature is after 3 p.m., and like at 1 p.m. it's the same. They do not change. Within the control volume may change, but not with the time. So after certain time the properties do not change. If they change, for example this becomes 100, then it is unsteady or transient. Control volume, mass control volume, energy control volume. And suppose the mass over here, suppose 10 kilogram, then it remains 10 kilogram after time 10 hours. With respect to mass, It is a steady flow process. Energy of this mass, suppose this is 100 joules, it remains 100 joules after 10 hours. It's a steady flow process. So let me show you one example to understand this more clearly. Do you want to have a early release or a mini break? We still have 12 or a few minutes. You want to have 10 minutes early release? Brianna says yes. Anyone else who supports the early release, or you want to have a mini break? Macy says yes. Okay, so I will release you early today at 8:20 ish. Okay, now let me finish this concept. So I'm gonna show you something. Look over here. I want to show you that the difference between the steady flow and uniform flow. For example, if you have a container, the mass is you turn the water is going inside, water level is here, time is 1 minute, and you open the flow, q is discharge, actually the discharge, this is just water is level is increasing. After 10 minutes the level is full. The mass over here was 1 kilogram, and now the total mass is 10 kilogram. Is this a steady flow or unsteady flow? What do you suggest your professor? Good job. Set says unsteady. Brainer says unsteady. That's good. So this is how you will learn that the steady flow, the mass and the energy of the mass remains constant inside the control surface. These are my control boundaries. Okay, these are my, let me show you. These are my, you have to define certain system. You, when you study something, you have to make some boundaries. This is always a good practice. Make some boundary. Either the real boundaries of the container itself are the boundaries, or if there is no container, then you can draw an imaginary boundary. And steady flow, we also call this a uniform flow. I will tell you the meaning of uniform flow, unsteady flow in a bit. Like, have you seen some nitrogen cylinders? If you have seen some gas cylinders or nitrogen cylinders, so what happens? Initially they are empty, but then they are filled by a certain valve system, so the nitrogen gas enters the system. So a uniform flow, this is also known as unsteady flow or uniform flow. Uniform flow means that at a certain time, for example, time 1 minute, temperature is temperature is uniformly distributed. So this you will study, we will study more when you come to that level. Okay, with that we are going to end this lecture. I will see you next week on Monday, and I'm gonna assign you some homework problem and reading sections you will study on your own. Thank you guys. Please type in.
Professor, I did have one question for you.
Yes, go ahead.
Are you going to be posting the lectures, like the voice recordings, on D2L, or are you just posting the slides?
What do you suggest?
Uh, I would prefer if you could post the voice lectures as well, but I didn't know if you recorded them.
I recorded, so I will do both. Okay.
Okay, thank you.
You're welcome. Bye bye.